Okay, what's going on, everyone? So we are going to be looking at our projectile motion test review. And this is specifically for horizontally launched projectiles. Now, I want to run through a couple of the beginning pieces of information. All right, expect these to be parts of the multiple choice questions. What two things are required of a vector quantity? Magnitude and direction during the path of a projectile. When is dy, or the height, the highest? It should be obviously at the top of its path. Projectile. It has a shape of a parabola. If it's launched horizontally off of whatever object, it is going to be half a parabola. Or if it's launched at an angle, it is going to be a full parabola. Number 4, the instant a ball is thrown horizontally with a large force, an identical ball is dropped from the same height, which would hit the ground first. They're going to drop at the same time. They're going to hit the ground at the same time because they're being launched from the same height. It doesn't matter because from the same height. Imagine if you're dropping something off of a table, they both have to fall that same distance to the ground. And the only thing affecting them in that direction is gravity, which will affect them the same. Obviously, we're neglecting air resistance still. In the absence of air resistance, the angle at which a thrown ball will go the farthest is 45 degrees, equal parts, all right, of x and y components. So it's going to give us the best combination of hang time and horizontal velocity, which will enable us to give us the farthest range. At what part of a path does a projectile have its minimum speed? At the top of its path. That could be whether it's launched off of the top right here, right at the top, right as it leaves, it'll have its minimum speed, or right at the top of its path if it's launched, tossed up at an angle. A projectile launched horizontally will hit the ground in 0.75 seconds. If it had been launched with a much higher speed in the same direction and from the same height, it would hit the ground. More time, less time, same time, same time. Again, because it's being launched from the same height, gravity is affecting it the same. So it doesn't matter. They're going to hit the ground same time, whether it's one is dropped, one is just kind of rolled off a table, or one is really rolled off a table with a greater speed. That's just going to affect maybe how far it lands away from the table, but not how far it falls to the ground. And again, gravity is the only thing affecting that, so the time would be the same. Projectile. Projectile is fired horizontally with no air resistance. It is the horizontal velocity. Is the horizontal velocity constant or changing? The Vx is going to be constant because, again, we're neglecting air resistance. There are no forces in the air. There are no forces, I guess, in the x direction that are going to cause it to speed up or slow down. Ball thrown straight up. At the top of the path, the acceleration in the y direction, -10 meters per second squared. Why? Because gravity doesn't just turn off. And again, we're talking about like a snapshot in time here, one instant in time. And at the top of that path, the vertical velocity would be 0 meters per second, not meters per second squared. You have to make sure you get the units correct. Meters per second squared deals with acceleration. Meters per second will deal with our speed and velocities. When it is launched at an angle, when an object is launched at an angle, is the vertical velocity changing or constant? It's changing. All right, as it goes upwards against gravity. This is our spot here. Okay, we launch it with some kind of vertical speed. Obviously, the Vx is going to be constant, but as it goes up, gravity is causing it to slow down, slow down, slow down. At the top, all right, your Vx is constant, Vx is constant. There is no vertical velocity, and then it changes direction, and it starts to speed up on the way back down. If you launch an object at an angle, how is the time for the projectile to reach the peak? compared to the time it takes to go back down. Same premise, all right, you're looking at your parabola. The time to take, all right, the time it takes to get to this top right here, if this was, 0.5 seconds, it would also take 0.5 seconds to go from the top back down for a total air time of 1 second. If you were to launch a projectile 30 degrees at an angle of 30 meters per second at an angle of 20 degrees, let's say it has a horizontal displacement of 59.4 meters. What other angle would give the same horizontal displacement, 70 degrees? Why? Any two angles that add up to 90 degrees will have the same x displacement. So if you were asked, okay, if something is launched at 30 degrees instead, what other angle is going to give you that same horizontal displacement? It would have to be 60. Why? Add them up, they give us to 90. And then as our flight angle changes from 0 degrees to 90 degrees, all right, the closer the object, all right, the closer the angle goes towards 90 degrees, think about it, the longer, all right, the longer in time it's going to be in the air. All right, it's going to spend more time in the air the closer you get to 90. And then we are going to be completing our problems down here. Now for the problems, we're doing a fresh batch here. But I want you guys, again, to label everything completely out in the steps. Put the little circles next to them for each of those steps. You have to be able to break down a problem and figure out what is given and what you are looking for. You will have, on your test tomorrow, you will have this equation sheet for you. You just got to know, when to use it and where to use it. Guys, if they're asking you for height, that's dy, vertical displacement. If they ask you for vertical velocity, like at what speed, right? If it's been falling for 10 seconds, 4 seconds, whatever, what is the speed at which it strikes the ground that way? Okay, that would be your Vy. But majority of the time, guys, our horizontally launched problems, we're not given an initial velocity in the y direction. So it's safe to say most of the time, if you're given a speed in a problem, you're given Vx. Horizontal distance, dx or delta x, it's how far away from the base, if we're launching something from up here, okay, how long or how far away does this thing land? How much distance does it go or travel? That is your delta x. Height, that is your dy. They want to know how far something fell or how high up something fell. Those are, your kind of key pieces, key phrases here. So stone is thrown horizontally from the top of a something high cliff. Well, if I'm thinking height is in the y direction, dy. So that is my height. dy is going to give me 572 meters. And what else do they want? How long is it going to take to reach the bottom? All right, well, think about it, guys. How long? Time. So in each of these problems, you have to list all the given pieces of information and then your question mark. That is your first step and your first total point. This problem is a 5-point problem. So you can get a point for doing this. Second step, write the equation for the question mark. Well, there are two equations for time. This guy right here, or this guy right here. You don't have delta x or Vx, you only have dy, so you were going to write this equation down first as your second step. All right, t is going to equal 2 times the height over gravity, 10. That's your second point. Third point, plop in the numbers. 2 times 572 over 10, square root it. And that comes out to be a total of 10.695 seconds. If you rounded it to 2 decimals at 0.7, awesome. Both answers are acceptable. So we have our answer completed and we box it. So 1 point, writing down all of our variables and our question mark. 2, writing the equation for the question mark. 3, start putting in the information. If we have everything, awesome, continue on, and then get our final answer. That is your 4th point, getting the correct value, and 5th point for having the correct unit. How far does the ball land from a cliff? How far does it land from a cliff? Like those kind of sayings. Delta X. That's what we're looking for here. If you're given a horizontal speed, horizontal is in the X direction. All right, so horizontal speed is Vx. That is 26 meters per second, and they tell us that it's in the air for 7.7 seconds. That's first point, first step. Second step, equation for the question mark. Covering up delta x, it's Vx times time if they're next to each other. So delta x is Vx times time. So that would be your second step, to write down that equation. And when doing so, all right, 2 is equal to the equation for delta x, Vx times time. Your third step would be to try and see, do you have all the information given for these? I have Vx, 26, going to write that. I have T, 7.7, I have that. Okay, cool, so that's it. That's the math that I need to show. That's my third point. Fourth point, get the correct number. When you multiply that out, it comes out to be 202.2. And the right unit, in this case, it is meters. So your dy and your delta x, guys, we're pretty much going to be in meters. Velocities, meters per second. And t, time, just in seconds. So this would be your fourth point and your fifth point. 17, a steel projectile shot horizontally, meters per second to speed, horizontal, Vx. 32 meters per second. From the top of a something high tower, that's dy. So 1050 meters. How far from the base of the tower? Again, how far from the base? How far away? How far from the base? Total distance. That's your delta x. That is what we're looking for. That is my question mark. There are no other pieces of information given here at this time. So, first point. Second point, you guessed it. Write the equation down for delta x. We just did it in the previous problem. So, awesome. Delta x is equal to Vx times time. Do I have Vx? Yes, I do. It is 32. Do I have time? No, I do not. So, in which case you have to go on a little side quest to solve for that before we can get our actual full answer. So, we can't use this equation for time because we're looking for delta x, so see ya. But if we have the height, we can use this. So, your third step then technically will be to write this equation to solve for time. Yes, I want the equation written like this first, 2 dy over 10 square root. Fourth would be to plug in those numbers. 2 times 1050 over 10 square root. And that will kick out an answer when we round it to 2 decimals of 14.49 seconds. Get that value is, your fifth point, because you need that in order to come back over here and to solve. Now, when you do so, that 14.49 seconds is going to come here, 14.49. And then all you're going to do, that's your sixth point. And then your seventh and eighth points will be to get the correct value and correct unit. This comes out to be 463.68, and the unit for distances or displacements here are meters. Box your answer, make it look nice and neat. Okay, and again, write your 7 and 8 in the positions that they belong to. Okay, 1, it makes it easier to grade. 2, it gives you a process in which to follow. A it gives you a process to follow, so you have a much easier time going through, all right, these things. You have a kind of plan of attack, all right? So it's a little bit easier, a little bit smoother for us. Moving on. Person standing on a cliff throws horizontal speed, that's Vx, 22 meters per second. And it hits the ground 53 meters from the base of the cliff. So you may be thinking, all right, is that 53? Is that height? Well, if you're not sure, maybe you can make a quick little sketch. So here's a cliff. All right, I'm throwing it with a speed out this way, and it says it hits the ground 53 meters away from the base. So if the base of the cliff is down here, the bottom, it lands over here 53 meters away. All right, you're 53 meters. Is that in the x direction? Yeah. All right. And also then it tells us, they're asking us how high is the cliff. So they want dy. So we have Vx, we have delta x of 53 meters, and we want dy. That is my question mark. So that is your first total point that you can have. Go to your equation sheet. dy, write down the equation for dy here. It's 1/2 gt squared. So we would write that. That is our second point and our second step. All right, do we have any of this information? Well, g, wait a minute, I don't know anything. Acceleration due to gravity, g. We've been using -10 for that, all right, for this entire time. So we would continue. So 1/2 of g, of what's 1/2 of -10? That is -5. So we can have -5 times t squared. Problem is, though, we do not have t. So we need to go on a side quest. Since we are looking for dy, we cannot use this equation for time. We have to use this one, where we have t is equal to delta x divided by Vx. So you have to write that equation down. T is equal to delta x divided by Vx. So that is your third point, your third step. Okay, once we figure out we don't have everything to solve for the initial equation. Fourth step, put in those numbers. Delta x on top, 53 over your Vx, which is 22. And then get that value. Comes out to be about 2.41 seconds. Now that is your fifth step, your fifth point. We need that time to come back over here for this original problem, all right? So for the actual solving piece. Now remember, it's t squared, so I'm going to put this in parentheses, 2.41, and I'm just going to put the parentheses inside so I don't forget. And another common little mistake would just be people forgetting that in their calculator, or they would just say, oh, -5 times that dude there. So I would do what's inside the parentheses first, 2.41 squared, just hit equals, get a number, times by -5. Comes out to be negative 29.04 meters as my dy. Now let me just quickly ask yourself, they wanted to know how high is the cliff. Can something be a negative height? No, it cannot be. Okay, so we were just going to drop the negative sign because dy technically is a displacement, which means if the ball started here, it landed 29.4 meters below. So we just got to make sure that we say, okay, 29.04 meters. Box your answer. All right, so let's go through the point system here. 1, variables, question mark. 2, equation for the question mark. See if we can put anything in. Okay, if we can't, side quest. That's step 3, write the equation for t. 4, fill in the values that you have. 5, get that answer and bring it back to the missing guy that we needed. And then 6 would be to complete that math. So let's put the 6 there, circle that. And 7, correct number, and 8, correct unit. Okay, 19. If I have horizontal velocity, that's Vx. Should start getting pretty easy with this. Vx, 18 meters per second. And it lands 137 meters away from the base of the cliff. By now, guys, that should just click. That's dx, or delta x, of 137 meters. Find the height of the object. Again, dy. That's 1. So second step, write the equation for dy. We just did it in the problem above, so dy is equal to 1/2 gt squared. Remember, we do have g as a given. It's -10, so I'm just going to cut that piece real quick. -10 times -10 times 1/2 is -5, but I need t, which I don't have. So again, side quest. I cannot use this equation because I'm asked to solve for height. I have delta x and Vx, so I have to write that equation first. That's third step. Fourth step, do that math. So 137 divided by 18, that would be your fourth step. And your fifth step would be to get that value, which comes out to be, when we round it to 2 decimals, 7.61 seconds. So that is your fifth point. Take that, bring it back, and that is, remember, our t, but that has to be squared. So 7.61 squared. I'll do that in the calculator first. 7.61 squared equals times -5 equals. So dy will equal this -289 rounded to 2 decimals, 56 meters. But again, they want to know what the height of this cliff was. So we're just going to get rid of the negative sign. 289.56 meters. That would be 6th point right here to show that math. 7th point, right answer. 8th point, right unit. And our last one. We have something hanging over a bridge, and it is 137.4 meters above the river. So thinking about that, that would be our height. All right, if a lead-weighted fishing line is thrown from the bridge with a horizontal speed, which is our Vx, of 20 meters per second, what horizontal distance is going to this be? Okay, they want delta x. First part. Second part, write the equation for delta x. Delta x is equal to Vx times time. Do we have any of those variables? We do. We have 20 here. But what we don't have is t. So before we can do this, we got to go side quest. We have the height, dy, so we can use this equation, which you must write. Step 3. 2 dy over 10 square rooted. Don't forget to do the square root in your calculator. Again, how we would do this fourth step, show the work. 2 times dy is 137.4. Once you do that, you're going to divide it by 10 and then square root. So I'm going to show you again how to do it in this calculator. 2 times 137.4 equals, great, divide that by 10. Now, again, this is going to be a mistake that some people make. They'll just write this answer down as the time. It is not. We have to square root. So to do it on this calculator, you have to hit the second button and we'll see where the x squared is. You see in yellow there is that little square root symbol. You hit that. Ah, darn it. I forgot to write down what was the answer to the last number. As long as I don't hit anything else, like times this, divided by... If you hit second, and then right here, the negative symbol where it says ANS in yellow, that will give us your answer from your last calculation. And then that will be our 5 point, if we round that to 2 decimals, 5.24 seconds. So that is your step 5. Again, I would like it please labeled everything like this on your test. Take this and bring it back. And what does that give us? 20 times 5.24. Delta x will equal 104.8. This is the 6th step to show the math. Seventh point for the right answer, 8th point for the right unit. And there you guys go. That is your review for your test tomorrow.